Howdy, Algebra 2. One of your classmates asked to go over this polynomial review question 3, letters B and C, so I'm going to do that with you, and then you can, again, anytime ask questions if you have to. So the question asks to state the degree and behavior, all intercepts, which includes your x-intercepts and y-intercepts, and then make an accurate and labeled graph. So that's the directions, and I'm going to actually start with letter C. Letter C is one that looks a little bit more familiar to what we usually do because this is in factored form. So I've got 1, 2, 3 factors. And so I can get my roots right from those values, where this one is not in factored form. This is standard form. And so I would need to get it into factored form to be able to graph it. So B is actually a little bit harder than letter C. So I'm going to start with C first, and we'll talk about all of the piece of information I can get from C right away. So the first thing, this X right here, and this is something that on your thing you did in class, a lot of you left this off, but this X does count towards the degree, and it's also one of your factors. So that has an exponent of 1, and this has an exponent of 2, and this has an exponent of 3. So when I'm in factored form, I can get my degree by adding those up. So in this case, my degree is going to be 3, 4, 5, 6. So it is an even degree. And notice that there is a negative out in front, and it's even with a negative lead coefficient. This information wasn't asked for, but that helps me figure out my end behavior. So I know because it is even, it either goes up and up or down and down, and if it's negative, that means it has to go down and down. So whatever's going on, my end behavior has to be going down on both sides. So if I had to write that officially, it would be as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to negative infinity. So down and down. So I got my degree, I have my end behavior. I'm going to get all my roots. So my x-intercepts are my roots, and they come from everywhere there's an x. So there's an x here, so that is a root. That is a root of 0. This is a root. It has a root of negative 2. This is a root. It is a root of 3. You guys are usually pretty good with that stuff. And I'm going to come up here, and I'm also going to indicate that because that's a 2, that means I'm going to bounce. So I put a B here. So when I graph this guy, I know at negative 2 I'm going to bounce. This is odd, so it does pass through, but it's 3. So this one officially would flatten out. So if you notice on my keys, sometimes I have F's written. It means it passes through at that value, but it'll actually flatten out. And I'll show you what that means in the graph. And then the y-intercept you get from plugging 0 in for x. And this is another one that caused you some trouble on that presentation that you guys did. But if I put a 0 in here, this whole thing becomes 0. So that would be 0 times 2 squared, and I do have to take these exponents into consideration, times negative 3 cubed. So if that's 0, if that x hadn't been there, I would have to square this and cube this and multiply. But because that's a 0, all of that equals 0. So when there's an individual x out in front, it's going to make your y-intercept be 0, 0 because it's a root at 0. So now I'm going to graph this guy, and I'm going to draw my grid. Just for fun, because I know what my end behavior is going to be, I'm going to put little arrows down here so that I know where I'm supposed to go at the end. I'm not going to necessarily hit those and match them up because it depends on all this other stuff, but I'm going to try it. So I have a root at 0, so I'm going to put a 0 there. I'm at negative 2, so I'm going to go over negative 2, and I'm going to put a B there so I know to bounce. And at positive 3, 1, 2, 3, I'm going to put a root there, and I'm going to put an F so I know to flatten down. And now this is how this helps me. I have to come up from down here. So when I come up, I'm going to hit that guy and bounce. I'm going to pass through this. I don't know exactly where I turn, but it doesn't matter. I got to flatten out a little bit, and that's all I mean by flatten out. And this one I very unofficially met up with that, but really this guy should come down here and be a little bit wider because I want it to actually be a function. So that is how I would do this one, and I am just being very picky about fixing my graph over here. There we go. All right, going up to the one above it. This is a little bit harder in some regards. but in some regards it's not. I can actually start with the degree. This is easier to get the degree because it's in standard form, so I just look for whichever one of these has the biggest power, and it's right there. So my degree is 3, which is odd, and it's a positive lead coefficient in front of that, so I have a positive lead coefficient. So if an odd degree, positive lead coefficient, my graph has to go like this somehow. So I now know my end behavior is as x goes to infinity, that's over here, y is going up. And on the left side, as x goes to negative infinity, y is going down, so y is going to negative infinity. So I've got my degree, my end behavior already. My y-intercept, this is standard form, it's just like a parabola. So my y-intercept is immediate. It's when I put a 0 in for x, and notice that if I put a 0 in for x here, that's gone, gone, gone. The only thing left would be 4. It's like that c value when we did standard form with the parabolas. That is my y-intercept. Now the trick on this is getting my roots. I am telling you one of the roots is 1, so I can start over here and just go, yay, roots, I know one of them. But I need to figure out the rest. So to figure them out, I have to divide, and I'm going to use synthetic division to do it. Again, this is a root, which means it is a factor of x minus 1, because remember those are opposites. And so the root I put up here, which is opposite of what the factor would be, and then I list my coefficients, 1, negative 4, and 4, and I'm going to divide this cubic, and if it's really a root, my remainder should be 0, and whatever's left will be a quadratic that I can factor. So I'm going to come over here, I'm going to drop that 1. 1 times 1 is 1. I add these up, I get 0. Multiply that by the box, that's 0. I almost wrote 1, but 0 times 1 is 0. Add those, negative 4. Multiply that by the box, negative 4. Add these, 0. This is my remainder. That's what I wanted it to be, 0. And since this started as a cubic, and I divided an x out now, this becomes my x squared term. This becomes my x term. And this is my constant, which means what I have left is I would have x minus 1 times x squared minus 4, because 0 times x is just 0. And I'm going to factor this because we did a bit with that back in quadratics. That is difference of squares, so that would be x minus 2, x plus 2. And so if I were to multiply these three things together, it would equal this. It would be cubic. Again, if I add up my powers, there's 1, 2, 3. And I have my other two roots now at 2 and negative 2. So now I can go graph this guy because I have everything I need. There's my very shaky grid. And let's see, I'm going to do this in purple, I guess. So I know my end behavior is down on the left to match this, and up on the right. I have a y-intercept of 4, so there we go. If you're really official, I'm going to put a 4 there. Roots at 1, 2, and negative 2. And notice that none of these have powers outside of them, so I'm not going to be bouncing or flattening or anything. I've got to come up through this guy, pass through the y-intercept, cut back down. I got to turn somehow and then shoot up. So this part didn't help me, and there's my graph. And that's those two examples. And this is definitely a good one to kind of maybe watch again or pause or go slower. But that's a good problem because it makes us use all of the skills from this unit. All right, hope you guys are doing well. See you later.